Hello. Today we will learn about the fundamental principles of signal and system. And first of all, we will see what are the signals. Basically, a signal is nothing just a set of data or information. What is data? What is information? The collection of something is known as data. And when it becomes meaningful for you, it is becoming the information. So there are different examples of data and or information like a telephone or a television signal, monthly sales of a corporation. So here these telephone calls are with the help of signals and it contains the data. Your voice is traveling in the signals in the form of sound waves. So similarly, television signals also contain some information for you. And if we talk about the monthly sales of any corporation, so it is also sort of a data. So this module deals almost exclusively with signals that are functions of time. Like here we will talk about x of t, that is the function of time. Now remember this thing that system is some entity that process a set of signals. Remember this thing that is known as inputs, and it is a system. System process these inputs and then it generates the output, and that output is also in the form of signal. So this is the concept of system that is going to process some set of signals to yield another set of signals. That set of signal that is in the form of output will be differ from the input. Obviously something will be performed by this system over those input signals. Now, if we talk about the size of a signal, so what is the concept of the size of the size of any entity is a number that indicates the largeness of strength of that entity. Let's suppose if I talk about the weight of an apple, if I talk about the size of a watermelon or size of an apple, so I can compare them in terms of their length, in terms of their strength. So if we talk about the signals, so the signal amplitude varies with time, and thus a measure of the size of a signal must consider not only the single amplitude but also its duration. Like here, this is amplitude, like if this is high peak, okay, this thing amplitude. So it varies. It varies according to the time. So if we talk about the size of the signal, so we can not only say this thing that it is the amplitude, but the amplitude over time. When time is different, the amplitude here you can see it is going to be different. Or the example of a signal over time, if you see its amplitude is different. So we will measure the size in terms of signal energy. So the energy of a signal x of t, we denote the signal as a function of time x of t. X of t is the function of time. Is described as the integral of the squared magnitude of its values. Yes. So whenever you will talk about the energy of a signal, how you can measure it? First of all, E of x is that it is you will denote the energy of a signal by E of x. After that, minus infinity to plus infinity, it's mean time can vary. Like here, if you see this, so it is starting from minus infinity, it is going towards the infinity. Then the squared, basically the here x of t is having magnitude or absolute value, that is squared. So you will be able to get the here a necessary condition for the energy to be finite is that the signal amplitude tends to zero as time tends to infinity. You can see this thing, the amplitude is having that tendency towards becoming the downfall, and it will become zero when time move towards the infinity. So a periodic signal with finite energy are called energy signal. Most of the system are having the energy signals. Then in this example, if you need to determine the suitable measure of the signal below, how we can measure? Here the x of t is given to us 2 e raised to the power minus t over 2. Then If we see the energy formula, this is the formula of the energy. Previously, I have explained to you. Now, what we did here, if you observe, from minus infinity to infinity, but the sketch that is given to you on minus 1, the amplitude of the signal is here, and that is what 2. So, and on 0, this is the function of x of t. Okay, so x of t is having down. So simply here you have 2 minus 1 to 0. During this interval, you have 2, the amplitude, or here you can measure 2 x of t. So simply 2 of square. Square is because of the formula. And then plus, because you need to determine the suitable measure for the signal, and your signal has from starting from 0 onwards towards the infinity, it is the function of x of t. Now here you will write the 0 to infinity, the function 2e raised to the power minus 2 over 2. And if you square them, what you will get? 2 to 4. Okay, this 4. Then here this 2 will be multiplied by minus 2. So this, they both are cancelled out. So what you will get? Minus t. Okay, minus t. Now you should apply the integration. So for e minus t, and you apply the integration, 0 to infinity. So what you will do? This first you have to solve for 0. So for e of 0, because t will be replaced by this 0, minus 4 e minus t. Okay, so this is the integration. Here we have minus, so it will come here, it will become plus, minus minus plus, because of this minus integration, simple integration. And then e raised to the power infinity, that will result in 0. Okay, so what we will have over there, that in order to have further multiplied, like here 4 is e raised to power 0, we have 4 plus minus minus becoming plus, it is 4. Sorry, not 0, like it is 4. Just simply solve the integration and you will get the 8. Now we talk about the signal power. If the energy of the signal is finite, infinite, it is not like minus infinity to plus infinity, infinite, then it may be possible to characterize it in terms of an average power. The average power is defined as, the only simple thing for the average power is that you will have the time t by 2 and minus t by 2, and you will divide it and t tends to this infinity, and other formula will remain the same, so you can get the average power signal. So these are the few examples that are mentioned over here, very simple, you can easily solve those. Like here, if we see this, show the that the energies of the signal below is 4. How you can show this? Simply apply the energy formula. If you see the signal is starting from 0 and on 1, so what it is? X of t, x of t is 2. So you will take the integration. So 2 times 2, 4, and 4 of t. So it's mean when you solve this 4t, 1 and 0. So you will have 4 upper limit, 1 minus lower limit. So that is 4 minus 0. So it is 4. Upper limit minus lower limit. So this is also show that the power of a signal below is this. So we need to consider only one period, that is from 1 over t. Like here if you observe, this is, we are observing this, then we are observing this. So 0 to 1, 0 to 1. That is equal to, we have to solve this one, x of t. Na? So absolute value once you will take, so the function that is given to us, e raised to the power minus t square. So what is the t? Capital T here. So we can have 1 by capital T, that is 2 over here. And then we will solve it and we will be able to see this. There are some useful signal operations as well. Time shift means you will add or subtract capital T from the small t, specific time. So we replace, in case of delay, if T is positive, the shift is to be the right delay. And if T is negative, the shift is to be the left or the advance. Now, useful signal operations, another, this is the example that you can solve for your understanding. And time scaling, another useful operation. Time scaling means multiply or divide, compression or expansion. For compression, we will apply the division if we want to compress, and if we want to expand, we will multiply. Then another operation, time reversal. So it is also very easy. Just you have to show if t is there minus, okay, like x of t results in a signal x of minus t. This is the reversal. The reversal is performed about the vertical axis, which acts as an anchor or a hang. And basically, time reversal forming the mirror image of a signal about the vertical axis at the region. Remember, it has the mirror image, the vertical axis. Another useful operation is combining operation. Like you can combine the time scaling as well as time shift. So you will have more better analysis of the signal. Now we talk about the classification of the signal. So in the next video, we will discuss all these classification. Thank you.